The last equation that we're going to really look in depth at, and one that we're going to use a lot, is called the point-slope form of a linear equation. Recall that if we're using slope-intercept form of equation, we have to know the slope and the y-intercept in order to write the equation. Point-slope form takes out one requirement, and instead of needing the y-intercept, we can use any point on the line. Now, point-slope form is actually pretty easy to remember because as long as you know the slope equation, then it's just a derivation of that. If we take our slope equation and we multiply both sides of our equation by our denominator, x2 minus x1, x2 minus x1, it eliminates from the left-hand side, leaving us with y2 minus y1 equals m times x2 minus x1. Well, if we go ahead and say that, well, instead of just having x2 and x1, we have, or y2 and x2, we have just any points x and y, we get our point-slope form, where m represents the slope, just like in the y-intercept form of our equation, and then y1 and x1 just represent a point, any point on the line. And so this allows us to write an equation, and then we can rewrite the equation in any notation that we need to after that. So given the slope of a line and the point, so let's write it as x1, y1, given the point 1, negative 5, we can write an equation in slope-intercept form. So we're going to start with our point-slope form, y minus y1, mx minus x1, and then once we have it in point-slope form, we can rewrite the equation in slope-intercept. So y1 is negative 5, our slope is negative 3, and x1 is 1. So we can simplify our equation. We have y plus 5 equals negative 3x minus 1. So this is the point-slope form. Now we can rewrite point-slope form into slope-intercept form. So we need to get it to look like y equals mx plus b. So we think about the features. Well, slope-intercept form has y by itself. So let's take this equation, we'll get y by itself. We'll also want to distribute so that we don't have those parentheses anymore. So we can go ahead and subtract 5 from both sides. We have y equals negative 3, x minus 1 minus 5. We can use distributive property to get rid of our parentheses. And then we can combine our like terms. And so then we get the slope-intercept form of our line. So we will be using point-slope form a lot as a starting point. And then from there, rewriting our equation into one of our 3 other notations. Let's go ahead and do the same thing here. But now instead of given the slope, we're given 2 points. But if we're given 2 points, then we can use our slope formula in order to find our slope. So first we want to find the slope. So we'll use y2 minus y1 divided by x2 minus x1. 0 minus negative 5 over 4 minus negative 4 gives us 5 over 8. So we have our slope, 5 over 8. And then we can use either point for our point-slope form. So let's just use for x1 and y1, let's just use negative 4, negative 5. You could also use 4, 0, and the math will actually be a little bit easier. So let me do the hard version. I challenge you to try with the point 4, 0 on your own and see if you get the same solution. So again, our starting point is going to be point-slope form. y minus y1 equals mx minus x1. So we start with y equals, y minus y1 is negative 5 equals our slope is 5 over 8, x minus x1 was negative 4. So now we can clean this up a little bit as y plus 5 equals 5/8 x plus 4. So now we have the point slope form. Now in order to get into standard form needs to match the format ax plus by equals c. And some of the common traits for standard form is that x and y are on the same side. X and y are on the same side of the equation. X is going to be first, and we typically like x to be positive. So we could either be adding y or we could be subtracting the y term, but we want the x term to be positive. And then the last thing is that we typically don't like fractions or decimals in standard form. We typically don't like fractions or decimals in standard form. We like to have integer values for a, b, and c, even though they're allowed to be real numbers. When we're writing it, typically makes it a little bit easier if we consider it without the fractions. So there's a couple different ways that we can approach this problem in order to solve it. So I like to get rid of the fractions first if I have them, but you don't have to, and I'll show you how that looks different depending on which way that you do it. So we're going to get rid of the fractions first. Actually, let's get rid of the fractions second. Instead, what we'll do, if I can actually get this to write correctly, 5/8 x plus 4. What we're going to do is we're going to go ahead and distribute our 5/8. 5/8 x plus 5 over 2. So we distribute that. And now what we can do is we can get x and y on the same side of the equation. So we're going to subtract 5/8 x plus 5 y plus 5 equals 5/2. We're going to move 5 to the other side. Negative 5/8 x plus y. And 5/2 minus 5. That equals negative 5/2. And then now what we can do is go ahead and get rid of the fractions, and at the same time we can also make x positive, because right now x is negative. So if we multiply both sides of our equation by the negative LCD, which is 8, when we distribute, we get a positive 5x minus 8y equals 20. And so we can distribute that. But keep in mind that when we did this, by getting rid of the fractions at the end, we had to deal with fraction operations, with whole numbers and mixed numbers, and we need to keep all of that straight. What I like to do instead is I like to get rid of the fraction in the beginning. So let's take a look at how that differs. If I have y plus 5 equals 5/8 x plus 4, if we get rid of the fractions in the beginning, we're still going to multiply by the least common denominator, which is 8. But when we multiply, on the left we distribute, but on the right, because this right side hasn't been distributed, it counts as one giant term, and so we only need to multiply once, which eliminates the denominators, and we have 5x plus 4 in parentheses. And so now that we've gotten rid of the fractions, it's a lot easier to simplify. We have 8y plus 40 equals 5x plus 20. We'll subtract 40 from both sides. 8y equals 5x minus 20. We subtract 5x, And then to make it positive, all we have to do is multiply everything by -1, which is just going to swap our signs. So you're free to simplify it any way that you want, as long as you can meet these ending conditions in order to get standard form. See how we got the same solution? So it's whichever one seems easiest to you. I have my preference, you may have yours. So now we want to find the equation of the line graph, right? The equation function notation. Now you may be tempted to try and use slope and y-intercept, but notice how our y-intercept here is not a whole number. So we'd have to kind of guess, is that number 2/3? Is it 3/4? We don't know. But we do have 2 points given, -1, 2, as well as 3, 5. So we have a couple of approaches that we can do here. All right, first thing we need is our slope and a point. We need our slope and we need a point. Well, we can use either point for that. Let's just say -1, 2. But to find the slope, we have a couple of different things we could do. We could use our slope formula. y2 minus y1, x2 minus x1. So we can have 5 minus 2 over 3 minus -1. And that gives us 3/4. But we could also just count. 1, 2, 3 units up. 1, 2, 3, 4 units right. So either way, we get our slope of 3/4. So now we can use our point slope form. Y minus y1, mx minus x1. The y we chose was 2. Our slope is 3/4. And the x we chose was -1. So y minus 2 equals 3/4 x plus 1. Now we need our answer in function notation, which is almost identical to slope-intercept form. Instead of y equals mx plus b, instead it's f of x equals mx plus b. We're replacing y with f of x. This just means y. So let's get y by itself. Y equals 3/4 x plus 1 plus 2. We distribute. And then y equals 3/4 x plus 11/4. And then all we have to do is change that y into the f of x, and we have function notation.